Good morning, children. In such a bright morning, let's begin to learn science. So, students, we had started our new lesson, that is lesson number 3, properties of natural resources. In a previous lecture, we had learned what is natural resources, and also through an activity we had seen the property of air, that was air has mass and weight. In today's lecture, again taking help with the activity, we are going to learn air's atmospheric pressure. So students, let's begin with the activity. First, take an injection syringe without the needle. Students, you have to take an injection syringe which is without a needle. Pull its piston and observe it as you do so. Do you know what is a piston, students? A piston, you can see in the picture, the back side of the syringe which can be moved is known as piston. So what we have to do? First, we have to take an injection syringe which is without a needle. Then we have to pull its piston and observe it. What will be our observation? Let's see. When we pull a piston, the piston can be pulled out easily. The piston is pulled out easily. The piston is moved easily. The piston then remains in that position even if you let it go. Students, till the point we are moving the piston, it will remain at the same point. Now, close the inlet hole of the syringe tightly with your thumb. So students, can you see in the picture how the inlet hole is packed with placing the finger on it? In such a manner, you have to do the same thing. So students, if the piston is pulled now, when we had closed the hole with the thumb, what happens? We require more force to pull the piston. And when the hole was not closed by the thumb, we required very less efforts to pull the piston. And also, when the hole was open, the piston we were moving at the point, it was remaining at that position only. But in the case of when the hole is tightly closed by the thumb, what happens? The piston does not move or does not remain on the specific point. So students, what is the activity? The first one, when the hole is open of the syringe, we pull the piston, it moves easily. The force required to pull out the piston in this condition when the hole is open is less. And when the inlet, that is the hole of the syringe, is closed tightly with the thumb, what happens? The force required to pull out the piston requires more. The force required is more. And also, when there is no thumb on the inlet, the piston stays on its position till where we have pulled it. And when the hole is closed, what happens? The piston does not remain on the position till we have pulled it. So why is it so, students? Because the molecules of the gases in the air are in constant motion. What does constant motion means? They do not rest for a single second also. They always moves. They always moves here and there. They always move. So, the molecules of the gases in the air are in constant motion. When these molecules strike a body, they create pressure on that body. So, students, when the air molecules are striking the syringe, our body over here is a syringe. What they do? They create pressure on that body. This is the pressure of air that we call atmospheric pressure. So students, what is atmospheric pressure? Let's see it once again. The molecules of the gases in the air are in constant motion. That means the molecules of the gas in the air are always moving. They are not at all at rest. So when these molecules strike a body, when these molecules hit a body, they create pressure on that body. And the body we used in this activity is a syringe. This is the pressure of air that we call atmospheric pressure. On pulling the piston with the inlet hole of the syringe closed, more space becomes available to the air in the syringe and it becomes rarefied. Students, what it is saying? Just listen it carefully. When the inlet hole of the syringe is closed, more space becomes available to the air in the syringe. So as a result, the pressure of the air in the syringe is lowered. As more space becomes available to the air, what happens? The pressure of the air in the syringe is lowered. Comparatively, the pressure of the outside air is very high. Students, the outside air pressure is higher than the air which is present inside the syringe. That is why when the pulled out piston is released, it is immediately pushed in. What happens? As soon as we pulled out the piston, it immediately released or pushed up. So, in this experiment is repeated, holding the syringe in different positions like vertical, horizontal or inclined. The piston is found to go into the same extent in all the cases. Students, what it is saying that if the same experiment or if the same activity is performed in different positions like keeping the syringe in vertical direction, keeping the syringe in horizontal position or keeping the syringe in inclined position, what's going to happen? The piston is found to go into the same extent in all the cases. And what it tells us? From this we can infer that atmospheric pressure is the same in all direction. Whenever the direction of the syringe change, the result we are getting is going to be same only because atmospheric pressure is the same in all the directions. So students, in today's lecture, what we had learned? We had learned what is atmospheric pressure and how it is created with the help of a syringe. And then we had also seen that the atmospheric pressure is the same in all the directions. Thank you so much. Students, watch the video attentively to clear all the doubts. Goodbye children. Have a nice day.